Right next to your iris.
Okay, so we're going to start on Unit 5. Like I said earlier, yes, we are finishing this before break. Okay, we will be taking this test the block day before winter break. Okay, so I'm not going to make you take it on the Friday before winter break. Hopefully, if everyone finishes their tests, I will come up with some sort of random, super, semi-easy extra credit activity for you to do. Yeah, that's it. Okay, so I don't know. So we are going to simplify and solve radical expressions. Simplify and solve radical expressions. So, does anyone remember what is a radical expression? Rational means fractions. Radical means the radical symbol. Okay, radical symbol, usually we call it a square root. Okay, kind of good news for you is we're only going to deal with square roots. There's not going to be any other number other than 2 inside that radical. Okay, so everything's just going to be square roots today. So let's start with, and there are quite a few examples, but most of them are pretty simple. Okay, so root 75. If I just ask you to simplify the square root of 75. Remember, when we're simplifying, okay, this one, what's the handle number here, technically? Technically, there's a handle number of 2. Okay, we don't write it in there because it's kind of a given. So what that means is you have to break down and make those little factor trees. What would multiply to give you 75? 3 and 25. You could also say 5 and 15. Doesn't really matter, okay? Break it down any way you'd like. I would suggest after you've broken something down to cross it out, just so you're not tempted to break it down anymore. Okay, and then 25 would break into 5 and 5. So this is super basic. Then, since we have a radical handle of 2, that tells you that you're looking for 2 identical things to come out from underneath the radical. So this would equal 5. Whatever's left behind goes back underneath the radical. So 5 root 3 is the answer to that. Okay, just simplifying radicals. This is all stuff that you've done before, for today at least. For today. So for number 2, okay, root 7 multiplied by root 35. Today's lesson is basically just all like real simple, make sure we understand before we get into the stuff that we're actually working on for most of this unit, which is imaginary numbers. Okay, so this is just kind of the review lesson. For this one, anytime you have 2 radicals and you're multiplying them, you can multiply the things together. So we want to rewrite this under 1 radical, 7 times 35. Now, you don't actually want to multiply those together because we're going to end up breaking them down. So just write them underneath the same radical, but then break this down. So 35 would break into what? 7 and 5. Okay, make sure you cross it out once you've broken it down. And then find pairs. So we have a pair of 7s. Those get to come outside. And that breaks down to equal 7 root 5. That's the answer we're looking for. Good. I would like this to be easy for you. Now, I know you've done this before, but everybody hates these. What if I gave you a fraction underneath a radical? Root 100 over 169. Root 100 over 169. Anytime you have a fraction underneath a radical, first thing you should do is break it up into 2 little radicals. So make it root 100 over root 169. Then you want to break out any pairs that you can. What is the square root of 100? Do we need to break that down, or do we just all know that one? Hopefully we know that one. It's just 10. Over, what's the square root of 169? 13. Okay, there is a list in the back of the classroom of square roots. Okay, it goes up through 15. Also on the kind of rainbow colored one, it's kind of small, but there are common squares that go all the way up to 25 there. Okay, you don't have to memorize them, but just recognize them is probably the best thing you can do. That's your answer there. If you can reduce it, you should. 10 over 13 does not reduce, so leave it just like that. For number 4, Number 4, I want you to simplify root 11 over 144. Root 11 over 144. So again, break it into two little ones. So root 11 over root 144. Are there any pairs that can come out of the square root of 11? No, we don't know that one. So it just stays root 11. Do we know what the square root of 144 is? 12. Can you reduce anything there? Nope. That's your answer. So the fractions really aren't that bad, hopefully. Okay, try another one. Number 5. I want you to simplify root 2 over 15. Root 2 over 15. So again, break these up to be a root 2 over root 15. Now, there is something in math that basically, there's a rule that basically says there can be no radicals in the denominator of an answer. Okay, you cannot have any radicals in the denominator of an answer. So does anyone have any ideas, and I believe we've done this before, how do you get rid of a radical in the denominator? Anyone remember? Whenever you have something equals, that's when you would square it. Okay, so when you're solving, yes, you square it. This one doesn't have, we're not solving for an x or anything, so you're not going to square it. Does anyone remember what we do, Thomas? Yeah?
You have to multiply it by something so you can get rid of that.
Right, we want to get rid of it, and that's called rationalizing the denominator. So you're actually going to multiply it generally by itself. Okay, so multiply by root 15 over root 15. And this is called, we need to rationalize the denominator. It's called rationalizing the denominator. To do that, all you really do is just write this under one radical. Okay, and we're going to write out, this is actually 2 times 15 over root 15 times 15. Now, this step isn't 100% necessary, so you don't have to write this step. If you do, obviously it's fine. Then we want to look for pairs. So you don't actually want to multiply them together before you look for pairs. Is there anything that you can get a pair of between a 2 and a 15? Nope, so that one you're just going to multiply across. So root 2 times 15 gives you 30 over, what's root 15 times 15? A whole 15. You have a pair of 15s. And then can you reduce root 30 over whole 15? No. Okay, you can reduce things if they're both under a radical or both whole numbers, but you can't mix the two. So that's your answer. Okay, that's called rationalizing the denominator. And we did that before when we were simplifying with the square roots and the cube roots and all that stuff. This is actually a little bit easier because you're always going to be working with square roots. So you never really have to figure out how many of something you need to get out of the radical. Try 4 over 5 minus root 2. I want you to simplify 4 divided by 5 minus root 2. Obviously, I just told you we cannot have any radicals in the denominator. So what do you think you would multiply by to get rid of this radical in the denominator? Any ideas? Root 2? Okay, don't write this down yet. I'm going to show you what happens. If you just multiply by root 2, you have to multiply by root 2 to all the parts, so don't write this down yet. That would give you 4 root 2 over, this has to distribute. So 5 times root 2 becomes 5 root 2 minus, what's root 2 times root 2? A whole 2. Did I eliminate my radical in the denominator? No, it just moved places. Okay, so what you actually have to do here is multiply by something called the conjugate. Okay, multiply by something called the conjugate. And this will definitely be in your notes quiz. Okay, so make sure you know what that's called. And the conjugate is essentially the exact same thing, but with the opposite sign in the middle. So you're going to multiply both the top and the bottom. Since this is 5 minus root 2, you're going to multiply by 5 plus root 2. Multiply both the top and the bottom by what's called the conjugate. Then we actually have to multiply. So since this is a monomial, so it's just one term, you're going to distribute it. Okay, distribute it. 4 times 5 gives you 20, plus 4 times root 2 is just 4 root 2. In the denominator, you actually have to FOIL these together. So FOILing these together, first times first, 5 times 5 gives you 25. Multiply the outsides together, gives you plus 5 root 2. When you multiply the insides together, you get minus 5 root 2. And what happens when you multiply just the last two terms together?
That's 2.
They don't cancel. Negative times positive gives you negative, and it's going to be a whole 2, because you have 2 pairs there, or you have a pair. So a whole 2. Now, if you combine like terms in the denominator, what always happens when you multiply by the conjugate is the radicals will cancel themselves out. Okay, that's why this works, to get rid of the radicals in the denominator. Then you want to combine anything you can on the top. So this would just be 20 plus 4 root 2 over, combine this, 25 minus 2 is 23. Now, can anything reduce here? No. Okay, if anything could reduce, you need to actually make it 2 separate fractions. But for this one, 20 doesn't go into 23, and 4 doesn't go into 23 either. So that's your answer. Okay, let's try one more that's really similar to that. For number 7, I'd like you to simplify 3 over 7 plus root 2. 3 divided by 7 plus root 2. Right, so to multiply by the conjugate here will be 7 minus root 2. So multiply by 7 minus root 2. I'm going to multiply the exact same thing on both the top and the bottom. So for the numerator, we distribute. 3 times 7 becomes 21. 3 times negative root 2 gives you minus 3 root 2. In the denominator, you're going to FOIL. So first times first, 7 times 7 is 49. The outsides, 7 times negative root 2 gives you minus 7 root 2. Insides gives you plus 7 root 2. And last, positive root 2 times negative root 2 gives you a whole negative 2. Now, you know that you've multiplied correctly if the 2 middle things, or whatever's attached to the radicals, completely cancel each other out. And these do. So we know that we did this correctly. Then just combine anything if you can on the top. These are not like terms. They stay separate. So 21 minus 3 root 2 over 49 minus 2 is 47. And can any of this reduce? Nope. That's your answer. Okay, that's called multiplying by the conjugate. Okay, the conjugate eliminates a radical in the denominator. Questions so far? Good? Okay, just a couple more, and now we're going to move to solving. So that was just simplifying. Now we're actually going to ask you to solve. Okay, so for example number 8, I would like you to solve 2x squared minus 15 equals 65. 2x squared minus 15 equals 65. Now, we want to get this x by itself. So whenever you're solving, you always want to undo the easiest thing first. So here, the easiest thing to get rid of is to move this 15. So you're going to add 15. We're using the additive inverse. So since it's negative, we add it. That leaves you with 2x squared equals 65 and 15 is 80. Then the 2 is attached to the x squared by multiplication. So to undo multiplication, you divide both sides by 2. And that'll leave us with x squared equals 40. Now, how do we undo a square? You root both sides. Okay, however, write yourself a big note. Okay, if you introduce a radical, then you must put plus or minus in the next step. Okay, if you introduce a radical, meaning if your original problem did not have a radical in it, and you insert a radical, you have to, in the next step, put plus or minus. Okay, this gives you two answers. If you don't put plus or minus, you're only going to get half the credit because you're only going to get one of the answers, and there should be two. So these, x squared gives you x equals plus or minus. Can I break anything out of 40? 40 breaks down to 4 and 10. 4 is 2 and 2. You do have to simplify these as much as possible. 10 is 2 and 5. So can I break anything out of there? 2's. Okay, this becomes plus or minus 2, and what's left behind is root 10. Make sure that when you write this, it goes after the plus or minus. Okay, this is not going to go before. The 2 and the root 10 are attached to each other by multiplication. It should be root 10 because there was still a 2 and a 5 left. So you're only taking out a pair of the 2's. 2 more and we'll be done. Number 9. For number 9, I would like you to solve 1/3 times x minus 4 squared. 1/3 times x minus 4 squared equals 11. 1/3 times x minus 4 squared equals 11. Before you can get rid of or get to the x, you first have to get rid of that fraction. How do you undo a fraction? Multiplies through the reciprocal. So what's the reciprocal of 1/3? 3. So just multiply by 3, or 3 over 1. It's the same thing. Okay, those are going to eliminate. So we get x minus 4 squared equals 11 times 3 gives you 33. Then to eliminate the square, we root both sides. Again, since I introduced the radical, you have to put plus or minus in the next step. So my equation didn't come that way, so that's why you have to put the plus or minus. Can I break anything out of root 33? No, doesn't have any pairs. So root 33. Then how am I going to x by itself? Add the 4. Okay. Now, when you add the 4, whenever you write these answers, you want to write them so that the whole number is first. Okay, so this is actually going to be 4 plus or minus root 33. Okay, they're not being multiplied, but it is attached by the plus or minus. That's the answer that we're looking for. Okay, one more for you and then we'll be done. Last one, for number 10. Simplify 3 times x minus 2 squared equals 40. 3 times x minus 2 squared equals 40. First thing you want to do is undo this 3. So how do you undo something attached by multiplication? Divide both sides. So divide both sides by 3. If you can, you should reduce this. This one does not reduce evenly. So we just are left with x minus 2 squared equals 40 over 3. To undo the square, you root both sides. Automatically put in the plus or minus. So x minus 2 equals plus or minus, since we have a radical with a fraction under it, break it up to become root 40 over root 3. Then what's wrong with this problem now? You can't have the radical in the denominator, so to rationalize that, you multiply by root 3 over root 3. I know this problem's kind of long. So we still have x minus 2 equals plus or minus. Can you take anything out of this one? The 40 and the 3? Can you break down 40 at all to take out any pairs? 40 is 4 times 10. 2 times 2, 2 times 5. So we can take out a pair of 2's. So this becomes 2. What's left behind? 2 times 5 times 3. So what's 2 times 5 times 3? 30. How about in the denominator? Whole 3. Then finally we can get rid of this, or get the x by itself. So to get the x by itself, you add 2 to both sides. And like I said earlier, you always want to write the whole part first. So this would actually become 2 plus or minus 2 root 30 over 3. And this fraction only goes with this part, not the whole thing. Okay, so that one's a little more difficult than most that you'll have to deal with, but that should be about the difficulty level of what you're capable of. Okay, homework is up on the board. You're going to be working on page 269. You're doing numbers 3 through 33 odd. Okay, 3 through 33 odd, and yes, it is out of your book. Anyone have questions? Good?